Half of you guys. I think everyone else is going to show up late. Alright, so has everyone gotten time to clone this repository? No. Well, if you want to follow along, you might need this. If not, you can just sit back, relax, listen to my beautiful voice. Okay, so my name is Phuc. I am with Data Science Dojo. So we are a boutique training company. We specialize in teaching data science to the general public. So what better way to start off that with real-time predictive analytics? Okay, so this is more of an advanced talk. So before we had like intro to predictive modeling, intro to random forest, intro to all that stuff. But this is like, once you have all that, how do you put it together? How do you operationalize all this stuff? And how do you keep it real time? That's the thing that matters, right? Because the dashboard can't be behind. All right. So let's talk about what the problems are. So all right. So this is a Twitter feed. This is 1% of a Twitter feed. Okay, so 4,500 tweets are coming into existence every second. So this is a live Twitter feed. So whatever it is, by the way, whatever you post on Twitter, I have access to it. Just FYI. So the idea is this is every tweet in the world that's coming into existence. So I'm sampling the stream. So I'm getting 1% of 4,500 per second. On top of that 1%, I'm only filtering the English tweets. So it's 1% of 1%. Okay, so even with all that, this is gigantic. This is a huge mountain of data. Okay, you can't even see this. Now the question is, how do we turn that, which is this, something unrecognizable, into something more like this? So if I, I'm going to stream some tweets. So in about 15 seconds or so, you'll see this start to change. So the idea is, you see this negative and positive at the end of it, right? Was someone happy about this tweet? Was someone sad or angry about this tweet? Right? So the idea is, as a tweet comes into existence, can we hook up a predictive model to it? Can we hook up machine learning to it and figure out if it was a positive tweet or a negative tweet in real time? Okay, so companies have been doing this forever, since like 2008. People found out that if you did this in real time, you could predict stock markets, right? Because if you can get the Twitter feed and you can calculate it on the fly, well, you beat everyone else in the stock market. Well, now every financial company does that, right? So it's fine. But before they were building custom code like C and C++ to get this done. Now it's gone to the point where it's you and me as a consumer, we can build this. All right, so that's what today I'm going to show you. So this is kind of like a hobbyist version of a Twitter sentiment feed. So basically, by the end of this talk, we should have a good idea about how this came into being, right? We take the tweet, right? Don't even have a pepper spray on me, negative, right? How did it know from these words to say negative, and how did it do this in real time? Okay, any questions so far? All right, so again, this is more of an advanced talk, so I assume you know what machine learning is. I assume you know what text processing is and what general pipelines and ETL all means, okay? So I don't have time to get into the weeds about the nitty-gritty stuff, okay? All right. Now, for those of you who just came in, there's pizza over there and there's also drinks, all right? All right, so how do we start this? Well, we might want to start with data, okay? So the idea is we need some sort of data set. We need, specifically, to make this simple, we need a supervised data set, which means someone physically sat there, probably some poor grad student, and looked at an individual tweet and said, this is a positive tweet, this is a negative tweet, right? Some poor linguistics PhD major probably sat there 8 hours a day and did this. Okay, so we're going to grab one of those data sets. By the way, there's lots of these types of data sets out there where someone scored a bunch of these data sets. So we know from the human the answer. Okay, so this is called supervised. Okay. Now, if we can build a model that can build from these past experiences on whether or not something's positive or negative, then we're in business. By the way, so I took out neutral. So usually if you do this, you would have positive, negative, and neutral. Well, I took neutral out just because I'm assuming if you guys are going to do this anyways, you would go out and you would build a multi-class classification model rather than a binary classification model. But for ease, we're going to do it in a binary classification setting. So you're either positive or you're negative. There's nothing in between. Okay? You can't be meh about something. You have to hate it or like it. Okay? So let's build our predictive model in Azure ML. And then let's do some text processing. Let's get our data. And then let's hook up a machine learning model. Okay? So let me just move this. Okay. So I'll be using today Azure ML. So this, by the way, this works in R, this works in Python. It doesn't really matter what platform you use. I just like that Azure ML has an endpoint that I can ping it to, right? I don't have to pack up my code, put it into some kind of virtual machine in the cloud, call that virtual machine, set up some kind of Flask server or something like that to call it. So in this case, Azure ML does that web deployment for me. So that's why I really like Azure ML for this purpose. AWS ML also does that, so if you are on an AWS setting, you can do that as well. However, I think you're just stuck with logistic regression for the purposes of this, okay? So I'm going to go to Azure ML. So studio.azureml.net, okay? So this is assuming you have an Azure subscription or a free trial subscription and you've set up a workspace, okay? So I'm going to log in. Just give it a minute while it loads. Okay, so I'm going to create a blank experiment. So the data set I have is a public data set. Okay, so let's actually read it in. So in the reader module, I'm just going to read it in as an HTTP. Okay, so somewhere out there, someone's posted this data set for me. Okay, and I'm going to just go to, and if you actually follow along, in the meetup page, I actually show you how to get there. So if I use the reader module, and my data source is a blob storage, so that if you're in AWS, it's the same thing as an S3. It's just really big cloud storage. Okay? And we're going to switch it to a public SAS, which just means there's no key with this blob storage. It's just a public blob storage. Right? And this is the URL of my data. So if I go to this URL, there should be a data file that wants to download. You guys see that? Okay? So it's a TSV file, so it's a tab delimited file, okay? And it does have headers. So I'm going to go ahead and read in this data set. So by the way, there's only 160,000 data points in this data set. You probably want 1 million or more-ish if you are actually going to build this for the purposes of production. Okay? But we don't have 18 hours to train a model, so I super subclass this down. Okay, so first of all, it actually reads out as, instead of positive and negative, it actually gives it a score between 0 and 5. It's kind of like a star rating, right? 3 being neutral, above 3 star being positive, below 3 star being negative, right? In orders of magnitude. So it's technically an ordinal categorical regression problem. But we're going to ignore that because today is less about machine learning. So we're going to build a quick and dirty model. We're going to do that, but we're going to cut a lot of corners. So every time I cut a corner, I'm going to try to tell you that I'm cutting a corner. Okay? So normally this would take hours or even days to build, but I'm going to build it within an hour. Okay? So I have to cut a lot of corners to do that. Is everyone cool if you're doing that? All right. So in this case, if I visualize the data, okay? So I got 160,000 columns and two columns. Okay? So first is the score. Okay, so 4 being positive, right, and 0 being negative. And this is the tweet, right? Hey dear, happy Friday. You already had your rice bowl for lunch? I don't know why you wouldn't use, I think he's using Twitter to talk to his wife or something. I don't know if that's a good idea, okay? So my data set's read in. I'm going to save it to my workspace, okay? So I'm going to save this data set X. So I'll call this, let's call this Twitter sentiment data meetup, okay? Yep, alright, so it's going to save it. So the reason I'm going to save it is because every time I rerun this module, it's actually going to call this reader module again and try to pre-parse this entire table. Okay? I don't want it to do that. I want caching to happen. Okay? So I want to speed up the processing here. Alright. so it saved the data set. I don't need this reader module anymore. I'm going to go ahead and delete it because I don't want it to rerun and parse that table again. Okay, because it's assuming it's a web page like msn.com. Okay, so this is great for a web scraping perspective because you can log in tomorrow, hit the run button, it scrapes msn.com tomorrow, right? It's an active page. Okay, but for the purposes, this is a static and eternal data set. It's not going to change. Okay, so that's why I saved it. Okay, that's the data I loaded in. And just to show you guys that this is not a rigged data set, it's the same one. 160,000 rows, 2 columns. Okay? Now, I can easily keep this a 4 or a 0, but I'm going to rename them. I'm going to recast them. Okay? Now, if you're used to R or Python, or anything else, even SAS, you have to convert things to categorical values that should be categorical, right? So, 0 and 4, those are numbers, but they should not be treated as numbers. They're treated as discrete values that are independent of one another, as separate choices that could have been made. Okay, so that's what we're going to do. So, we're going to take a metadata editor. So metadata is basically data about the data. So we're editing the data about the data. Okay, and specifically, we're going to make sure it's a string, and we're going to make sure it's a categorical value. Okay? And also, this is a pro tip for you guys who are just starting out machine learning. I'm not going to work on 160,000 rows. I don't have time to sit here, hit run, wait 10 minutes for this whole thing to process through 160,000 tweets. Let's process 9 tweets at a time or so. So this whole thing speeds up. So I can speed up my processing, okay? So once I'm ready and the logic is rock solid, I will go back and actually I will process the entire data set. Okay? So in Azure ML, there's something called partition and sample. Okay? So in this case, I'm just going to sample this way down. Okay? Like, let's get like 0.1%. Okay? So that will give us like 160 tweets. Okay? And also, while that's running through, okay. So if I run this, I need to tell it what column I want to set categorical. Okay, so in this case, my sentiment column, the 0 and the 4, are the ones that need to be set. Okay? So we got that. So categorical casting is done. Okay, so we've explicitly told our computer, or in this case Azure, that when you're doing this, don't consider 0 and 4. Don't take a median, don't do math on this column. Okay, so it looks like this is done, but it's still thinking about it. So if I visualize my data set now, at the very bottom of this, I can see that there's down 160 columns, right? And it's a categorical feature. You guys see that? This is important. So the next thing I want to do is, just for clarity, I don't like 4 and I don't like 0. It's not very descriptive. Okay, so in this case, I think I would use something called categorical. Alright, I think it's called group categoricals. So in this case, I want to rename my levels. Okay, so this is done with one line in R. This is the same thing. Okay, so what you want to do is I want to grab all my categorical columns, which in this case I only have one, right? My sentiment. And what it's going to do is I can do an in place, which means if you see it, just replace it in the same column, or I can append it as an extra column, right? So then I end up with 3 columns instead of 2 columns. But I'm going to do it in place because I just want to do replacement, and I got 2 levels, right? 0 and 4. So my default level, let's do this actually first. So the level 1, right? I will call this, let's say this is positive, right? So, and I'll put a 4 here. So what does this mean? Anytime it sees a 4, it's going to replace it with the word positive. Okay? And if it doesn't see a 4, I'm going to replace it with the word negative. Okay? And it's only going to do this for the categorical values. So it won't go through my tweets, and it won't change my tweets, because that'd be bad. Because I'll be adding a lot of words to my tweets. Okay? So if I run this, yeah. So I can answer questions while this is running. Huh?
And this is your URL.
So if you go to the GitHub repository, it's the third bullet point. It tells you how to read in this data set. So if you go to MeetUp.com, the GitHub repository is the first link. Okay? Alright. So in this case, if I visualize it, there should be things called positive and there should be things called negative. Perfect. Right? Negative and positive castings. And look, it's categorical. Beautiful. Okay? Now we got to do some text processing, right? Because the thing about machine learning is that it likes math, and it can only do math on structured data. In this case, the tweets are not structured anyway. So we need to do something called text processing. Specifically, we need to convert it into a matrix that it can apply math upon. So some of you guys might notice as a term frequency. Some of you might notice as tokenization, okay, or binarization. So basically, every word is going to need its own column, 0 and 1, right? Does this word exist in this tweet? Yes or no? But specifically, we're going to keep it as a count, okay? 0 and 1. How many times did this word appear? Maybe 3 times? Okay, we need to keep that as right down to number 3. Okay, so every single word in the English dictionary should get a word, so should get a column. Right? Does anyone know how big this is going to get? How big is this data set going to get?
Every single word.
60,000? Well, what about slang? What about all of Harry Potter? What about Lord of the Rings? How many words are made up in there? What about company names? I'm sure Chevrolet is not in that book. Right? What about rap songs? Yes. Lots of words in the English dictionary. So what do we got to do? We got to filter out a bunch of those words before we can build this matrix. If we build this matrix now, it would be like 12 trillion columns. Just FYI, we do not have a Hadoop cluster. We cannot do that right now. Okay? We could, but that's a different meetup. Okay? So, for now, we got to make this from big data, because right now, by the process of doing this, we're going to create big data. Okay? If you guys know, big data is very expensive. It's very time consuming. You always want to bring down big data problems to manageable data problems. Always. You'll save so much money that way. Okay? So, in this case, we need to do something called text processing. Alright, so how do we do that? Well, for this, yep. Let's take a 5-minute break while you guys get pizza. Apparently it's here. Okay?
It's on that counter.
Alright.
Don't want it to get cold, so we're on the counters over here now. So feel free to get a refresher drink, grab some pizza, and all that.
Alright, so last time I talked about this matrix going to be freaking big. Like 12 trillion columns big. If we actually fed Twitter into this thing. And by the way, the act of adding a hashtag to a word, that makes it a separate word. The act of adding an S to a word, that makes it a separate word. It's still the same word though, right? So, in this case, there's a bunch of transformation that needs to happen. So first of all, we need to remove stop words. So stop words is the, as, in. The words that basically, they help us with syntax and they help us with grammar, but they don't really add any value from a predictive modeling standpoint. They don't hold any meaning. Okay? So we need to remove special characters. So that's basically the hashtag, $, the dots, the periods, the dashes. Okay? We also need to take out numbers. Okay? So this may or may not change your data. So sometimes, for example, I think in Harry Potter it's platform 8 3/4. The 8 3/4 is important, but for the most part, we can just do a global remove numbers. Okay? We also need to make everything lowercase. Okay? So to a computer, capital female is different from lowercase female. Those are considered 2 different words now, because they're using separate bitmaps. Okay? Then we need to do something called stemming lemmatization. Okay? So again, lots of words look the same, spelled differently, but they convey the same thing. Run, ran, running. It should be one word, right? In every instance where you see run, ran, running, replace it with the word maybe just run. Okay? And that's how it is. That's what we're going to do. So in this case, let's see if we can get this 12 million or 12 trillion column matrix down to like a couple 100,000. Okay, and also we only have 160,000 tweets, right? That's actually, even if we fed all of it through right now, we still wouldn't see all the words. Okay, a lot of the words, especially in the Oxford Dictionary, a lot of words are historical. You won't see them. Okay. So let's do this. Okay. So to do this, we're gonna do a few things. Okay. So we're gonna call upon the powers of R to help us. You can do this in Python as well. It just so happens that Microsoft released a really cool text processing package. Okay. So in this case, we're gonna bring in an execute R module. Okay. Boom. All right. And we're going to connect it to our data set. Okay, so in this window, it lets me just type in R. Okay, so R is a statistical programming language built from the ground up to do stats. So it's a favorite among data scientists to use for machine learning. Okay, it's pretty weak on text processing, FYI. So usually if you want to be doing text processing, you'd be doing this in SQL or Python or something that is in R. Okay, so R can do pretty good transformation stuff, just not a lot. Okay, so if you do switch to like an actual Twitter pipeline, you might want to switch the code out here to Python or something else that's more scalable. Okay? Now, if you look in your folder, I've added you a few things. So if you look at the Azure ML code, I have a list of stop words. So if I open it up, it says the, and, you, for, that, day, not, get, today, HTTP, think, back, actually, think. No, this is used too much. By the way, machine learning cannot detect sarcasm yet, so don't even try. Okay, we are probably a couple decades away from detecting sarcasm. Because to detect sarcasm, you have to predict someone's mood and every interaction that they had prior to that. So that's not there yet. So ignoring sarcasm, I think that's why we took out think. Okay? Really? So does everyone see the word really here? It's replaced with a Y, or an I instead of a Y. So when you stem and levitize, all Y's are replaced with I's. And secondly, there's also the word real and really and reeling and all that good stuff. So that's every instance. This is a sample where you see a custom levitized word. Okay. All right. So now that we have, and by the way, so if you were going to do this yourself on your own domain, let's say you had a cooking recipe website, your stop word might be different. It might just be the word recipe, right? Because the word recipe is going to appear in every single document, right? Because they're all recipes. So your stop words will change based upon your problem. Okay. So this is our list of stop words. So what I'm going to do is I'm going to import them into Azure ML. Okay. So to do that, I will go to New, Dataset, from Local File. And then this is an instance where I will upload that data set. So I'll go to that MeetUp folder. And I'll go to Streaming Data Nano, not that one. Real-Time Sentiment. So in the Azure ML code, I have a list of stop words. Okay? And it does, let's see, Seattle, let's see, stop words, MeetUp, Seattle. Alright, so I'm just going to do camel casing to make it easier when I reference it in the code. Okay? Alright, it's going to load in that data set. I've also included a text processing package. So this is an R script that gives you functionalities to do text processing. So everything that we talked about earlier, stemming, levitization, character, like the character map, the binarization, and all that stuff is, well, not binarization, but the stemming, levitation, that's in there. Okay? So we're also going to upload this script. Okay? So to do that, I will also go to New, Dataset, from Local File. I know it's not a data set, I know it's a script, but this is how you get data and things into Azure ML. Okay? So I'm going to upload the text processing script. Okay? 2 right there. Okay. So in this case, it's going to import that for me. So if I search on the left after I've imported my data set for the stop words, okay, so in this case I will drag this in. And if I visualize it, there should be a list of 250 stop words. Yeah, 250 stop words. Okay? And in this case, so if you think of the execute R module as a self-enclosed, encapsulated virtual environment to execute R. Okay? How do you get data into that virtual environment? Is you just drag it and connect it, right? So in this case, I'm connecting 2 data sets. I'm connecting my actual tweets, and I'm connecting my list of stop words. So these are my own custom set of stop words that I've added. You might want to add a lot more, but I don't have access to linguistics right now, so I can't get the full list for you. Okay? But we'll publish a lot of them up there. Okay? So in this case, I also want to bring in my text processing zip. Okay? So if I look at that, so on the right-hand side, it takes a script bundle. So which means you can add external files to this execute R. So execute R has a couple hundred, almost a couple thousand packages pre-installed on it. But it just so happens this is a custom text processing script. So I'm going to reference it here. So if you're more used to R, this is the same thing as saying library. Okay? Or in Python, if you say import, or Java, import. Okay? So I'm going to connect it there. Now if you go to the MeetUp folder, I prepared you some R code. Okay, it's under text.processing.r, or actually it's under text processing R script. So it's this one, text processing script. Okay, .r. So what am I doing here? Well, I'm setting I'm setting my fields. Okay, so in this case I want to do everything. Okay, so this text processing package adds a really good interface for me to just say, do I want stemming? Do I want stop words? Do I want numbers? I can turn it on and off with a switch, but just by changing it to false. Okay, so it's going to be different for every package. This package I'm using, it's a simpler package. Now if you do this in production, you might want to use Python and a package called NLTK, Natural Language Processing. Okay, so that is the super robust version. This is like a shovel. That one's like the backhoe. Okay? You want to be using that one. Okay? But this is just for demonstration purposes. We're just going to do this quick and dirty. So in this case, if I look at this, it's going to bring in my. So by the way, so map import 1. What does that mean? It means this guy right here. The import dataset 1 node. Okay? So that by contrast, what does that mean? That means this is man import 2. Okay? So this is Azure ML specific keywords, okay? Not our keywords. And in dataset 1, which I've described as man import 1, I'm going to grab the text tweet column. You guys remember what column that was? That's just a column with the tweet body. We don't care about the labels at this point. We don't care if it's positive or negative. We're just transforming it. We don't care about machine learning yet. And now I want to bring in stop words. So my stop words specifically are going to come from man import 2. Okay? Man import 2 being the second data set I dragged in. Okay? So in that, I'm populating my stop words. And now, this is where I actually call the package that I referenced earlier. So the package I called earlier is listed down here. Okay? src text.processing.r. But if you notice, I called mine text processing 2. You guys see that? So this is where I need to change it. Okay? And now I'll bring the label back in. Okay? And after it's done cleaning that text, I'm going to put it back in. So I'm building a new data frame. Okay? I want that 1 by 2 column again. Or in this case, it'll be 1 by 3. Okay? Because I'm also bringing back in the text. Okay? So I'm replacing in place the text body, right? So after I transform it, I don't care to retain the old text body. So I'll still come out with a 2-column kind of data set. Okay? So if I copy this and paste it into the R script or into the R module, and and I run it, hopefully everything will be okay. Hopefully. So it's going to go through, and it's going to do my cleaning for me. And you'll be really glad that we only have 160 rows instead of 160,000. Okay, because this takes a while. Right? Because it has to go through each and every single word and each and every single character and scan. Alright, looks like I had an error. Let's see what's wrong. I'm going to view output log. And this is the most helpful thing I've ever seen. Alright, so it looks like I made a mistake by calling it 2. And I'll tell you why. Because it's actually going to reference this guy inside of the zip folder. So the guy inside the zip folder doesn't have a 2. Okay, so that's why. Alright, so let's go back and fix that. Alright. Let's cross our fingers and hope this works. So by the way, this is a live, since this is a live demo, I cannot guarantee if anything's not going to work. So it's okay, I got backups. Okay. Alright, looks like it was successful. Okay, so if we visualize this, okay, let's see what happened. Now, we actually don't know what this looked like before. Okay, so let's see, so project edit render looked like fixed hour. Okay, let's see what it did. I think if I just copy this. Okay, so that's what it looked after. Let's see what happened to it before. Looks like it was much longer. So, for some reason, it filtered out the word final. It took out that dash, you see. It made everything lowercase. See, the is gone. The word editing is now edit. Right? Rendering is now render. It took out is done, comma, the. Okay? Looks like S, okay? So you can see that we took out a lot of the non-meaning words. So when we convert this to a matrix, okay, a table of words, we filtered out most of them. Okay? Alright, what are we going to do now? Well, now that we filtered out our words by a lot, and I mean by a lot, okay, like magnitudes of 10, okay? So now we got to do something called building a term frequency matrix. Okay, so some of you guys might know this as TF-IDF, tokenization, okay, or just a matrix. Okay, but it's just, long story short, it's a table. Each word gets a column, and you record whether or not the word appears in that tweet per row. Okay, so Azure ML has a specific implementation called feature hashing. Okay, so what this is going to do is every single word that it sees, it's going to go ahead and give it its own column, whether or not that word exists or not. Okay? Whether or not that word exists or not. So I might have a bunch of columns that are just completely blank. No. Right? So hash size. So hash bit size. What does it mean? I'm defining how much memory I want this to take up. Okay? Which means it's defining how big my columns can get. Okay? So in this case, whatever it is in here, it will be 2 to the power of this column size. So right now, if it was feature hash 10, I'd have enough space in my matrix for 2 to the power of 10 columns. Okay, so let's look at that real quick and start calculating performance matrix. Alright, so here we take out our handy dandy friend Excel. Okay. And let's calculate how big this really is. So 2 to the power of this cell. So we can see this is where we can control how big that matrix ends up being. Okay? So sure, we can do a 10 hash bit feature hash algorithm. However, we would only have 1,024 columns. Okay? That's only enough room for 1,024 words. Even though we filtered out a lot of stop words, I can guarantee you we have a lot more words than that, right? But however, the trade-off is the more bits we add, the bigger our data set is. It's going to take more computing power. It's harder to find clusters. It's harder to find distinctions. Our data becomes very sparse. Okay? But most of all, for computing performance. Okay? So normally I would do a 21 gram. Okay? But in this case, we don't have that much time. Let's just do 17. Is everyone okay with 17? Okay? Now the next part of this is n-grams. Alright, n-grams means how many words should you consider in unison? Okay? Alright, so there's the example of roast as a word, beef as a word, and roast beef. Those are 3 separate meanings. However, if you kept it at m-grams, if the word roast beef came up, the computer would not see it as one word. It would see it as 2 words, independent words of one another. Okay? So in this case, I wanted to consider things like jumbo shrimp. Okay? So that's why I have 2 there. Now, this is going to exponentially increase your footprint as well, memory footprint as well, because now you're considering every single combination of 2 duplicate or joins of the word. Okay? But just to be safe, let's do that. Alright. So, actually let's do 15 because I'm afraid how long this might take. Actually, yeah. I want to run this. So this is going to convert, it's going to go through every single word and put it into a matrix for me.
So what if the number of tokens are larger than the
If-
drops around words?
So, a good question. What if there are more words than the number of tokens? A lot of words would overlap. Like birthday might be fit into the same column as happy. Okay? So you get a lot of conversions there. I would look up a paradox called the birthday paradox. How many people share the same birthday as you? You'd run into the same problem. Duplicate collision. So anytime you have any kind of hash algorithm, you can get collisions. As in 2 things fighting for the same spot in memory. Okay?
So this has no collision resolution.
It does not. It just puts it in there. And you actually don't know if there was a collision or not. Okay, so if I were to do this, I would do it much more. Okay. Let's see, actually, let's look at this.
What's a realistic hash size you use interpret if you were to do this for business?
Yeah, I would probably do 21 plus. But that requires a lot of computing power. Because you're going to end up with trillions of columns real quick. Okay, so if we look at this, it created me 65,000 columns. Okay? Very sparse matrix. Okay? And most of them are going to be zeros. Right? 0 meaning that word did not exist in this context. And I can guarantee you that if I scrolled over, I would probably never find a 1. Okay? Because the chances of finding these specific words out of 665,000 columns, very slim. Okay? Okay, so now that I've done that, now that I have my matrix, I no longer need that original text body. I'm going to drop it. Okay? It adds no more value to me from a predictive modeling standpoint. So I'm going to begin with all columns and exclude a certain column. I'm going to exclude text column. Remember, this is the original tweak before I transformed it into a matrix. Okay, I'm going to drop it. And now it's ready for data mining. Okay? I have a bunch of columns of zeros and ones and a categorical supervised column. Okay? So this is right for machine learning now. I got no missing values either. Okay? So now I have Now I need to pick an algorithm. So specifically, this is a two-class classification problem. Okay? But which algorithm should I go with? Okay? So, let's do this a quick and dirty way. And I'm going to bring up a handy-dandy cheat sheet. Okay. So FYI, there's a lot of, it depends which algorithm you should be using. Okay? It's a really big it depends. But if you're beginning at machine learning, this graphic will give you, it'll point you in a safe direction. Now once you start getting advanced in machine learning, you'll know the intricacies of these, hopefully, some of these algorithms. Now, by the way, you shouldn't go out and learn every single one of these, okay? That's just not a good use of your time. That's a lot of PhD papers. But specifically for our case, we're starting here. Okay, we're predicting categorical values, yes. Okay? And we're predicting a binary classification, so two values, right? Positive or negative. And specifically, we have more than 100,000 features. Okay? So in this case, it's pointing me to a two-class support vector machine. Okay? So that's what I'm going to go with. So, again, we could do a meetup on each and every single one of these algorithms. And I'm serious about that. Okay, we had one recently on Intro to Random Forest. Alright? And we might do each and every single one of these one day. Okay, so just stay tuned on our meetup page. Okay? But for now, I'm going to use a support vector machine. And a support vector machine is very fast at receiving predictions, or getting predictions, right? So if you send something through something like a neural network or a decision tree, it has to go traverse through thousands of if-else statements, okay? But the end result of a support vector machine, it's vector multiplication. AX plus BY plus, it looks like a linear regression, really. So it comes back really quick, because vector multiplication is very fast, okay? So in this case, we're going to use a support vector machine. Okay? I'm going to drag that in. Alright? And there's one thing that I forgot to do. So, normally, you want to normalize your data. So normalization means, right now it's a word count, right? If a word appeared 3 times, a 3 would show up, right? But generally speaking, if I fed in Lord of the Rings versus a tweet, all the words in Lord of the Rings the frequency of them would completely overload the model towards positive or negative on the other, depending on what the bias was in your model. Okay, so in this case, you want to normalize everything down to percentages. You take the max times the word appeared and divide it by the counts. So counts divided by the total number of words, right? So everything gets normalized down to a certain scale. Okay, so you get back zeros and ones, right? On a pretty even scale, which is fine. So you don't have to do this with Twitter data because every tweet is maxed out at 250 characters, was it? So you're not going to have that kind of differences in text counts. Okay, but normally for good style, we want to normalize it. So I think there is a normalization module. So if I want to normalize it, so there's lots and lots of different types of normalization. The easiest one is just you take the min and the max. This is exactly what I just described. You take the counts and divide it by the max word count in that column. Okay? And I'm going to do it for all numeric columns. Because remember, those 65,000 columns or whatever, they're all numeric right now. And we explicitly said, treat positive and negative as a categorical value. So it's not going to count that. Okay? So once we normalize that, we can build and train our model. So I'm going to hook up my support vector machine to a train model module. Okay, so this is going to this is a blank algorithm, a set of instructions on how to build a support vector machine. Okay, we feed it data, and specifically, learning happens in here. The execution of we take all the data and we learn from those experiences and we build our support vector machine. Okay, and specifically, if we build a model, how do we know that it performed well? Well, we have to score. Remember, this is a supervised data set. We know the actual answers. Was it actually positive or was it actually negative? So when our model tells us it's positive, we can cross-check on what the actual answer was. Okay? So I'm going to connect this here. But what do I connect it to? Well, normally, I would want to split this data into a training set and a validation set. So the test set is going to be sacrificed to build the model. The validation set is, I'm going to hide it away from my machine learning model. My machine learning model should never see this. After it's built, I'm going to go ahead and say, hey, these are a bunch of new data sets that I'm simulating as future world data. The only caveat is, it's still a supervised data set. I still know the actual answers, so I can compare predicted with actual. Ground truth with predictions. Okay? So I'm going to split my data. Now in the industry it tends to be 70-30. Now if you come from a SaaS background it might be 60-30-10. But ignore that for now. So in this case, I'll say 70% go to node 1 and 30% go to node 2. And I'm going to go ahead and launch my column selector and say I want it to predict the sentiment. Okay? And, you know, it's generally good to evaluate this at the end. And remember, so the actual prediction happens in the score model, right? So out of the score model comes a trained model. So if this was a decision tree, a tree would come out of here. Okay? The score model says, takes that tree or that model or that algorithm where you figured out the coefficients and go ahead and take it and use them as predictions. Okay? In this case, we're going to feed it the validation set, which is about 30%. We're going to go ahead and evaluate. And remember, we're only training on 160 data points right now. Right? So the performance of this is going to be spectacularly terrible. Right? Because it's only going to see each word at least maybe once. Just once. We haven't fed it enough data to see more than once of the same word. Right? Maybe Leonardo DiCaprio should be positive. But, right? This thing has only seen Leonardo DiCaprio once. And it was negative that time. Alright? Actually, you should put Leonardo DiCaprio and Oscar together. That would be probably negative. Alright. Any questions so far while this thing is running? Yeah.
Yeah, can you explain the lambda parameter a little better and how it compares to like alpha and either ridge regression or elastic net regressions comparatively?
Sure, Brian, you want to?
Can you repeat the question about that?
Can you explain the alpha parameter in the support vector machine a little better and how it compares to like an alpha parameter, say in like a ridge regression or elastic regression?
Actually, would you bring it up for me so everyone knows what we're talking about?
Yeah.
So we've got a lambda here. So support vector machines are kind of an interesting kind of model. So you basically got a lot of different types of models, but fundamentally you've got kind of non-parametric decision-based models like random forests and boosted decision trees and things like that, and neural nets kind of fall into that too. And then you've got regression models that try to fit data points, sort of like linear regression or logistic regression or something like that. SVMs are something a little different, but they look a lot like regression. So the lambda here is probably, I don't remember offhand, but it's probably a gradient descent learning rate. So essentially, this is going to be similar to a learning rate that you'd see in a logistic regression setting or a linear regression setting.
It's a drop in the local minimum, the amount of drop in the local minimum to find the local minimum?
Yep, exactly. So support vector machines, essentially what they're looking for is actually a local maximum, not a local minimum, but the concept is the same.
Thank you, Brian. Our PhD physicist, everyone. So, according to this, wow, okay. Okay, so according to this, our model is God. It knows everything. So, this is with 160 rows, right? So once we feed it real data, it's probably going to drop down to about 77% accuracy. Okay? So, but for now, this is ridiculous. This is like, let's ship this, let's monetize it, let's go home after this. Okay? Okay. And you can tell 100% accuracy, 100% precision. Alright? By the way, you want to be very wary. So if this is your first intro to machine learning, if you see a number greater than 0.9, that is suspiciously good. Okay? If it is 0.9, you should actually do more due diligence to figure out why it's that high to begin with. Because chances are you're overfitting. And if you overfit and you release this model into the real world, you're going to drop down to like 0.6 real quick. Okay? Just FYI. Okay? Okay, so now, alright, so I'm just going to skip. So normally this is the part where the data scientist spends a week on. So they do cross-validation, they do a bunch of third-party tests, they do a bunch of other parameter tunes, they do a bunch of stuff. Okay? But in this case, I'm just going to say this is good enough. Okay? I'm just going to deploy it. Okay, is everyone okay with that? Okay, so I'm skipping like a week's worth of work here, but demo purposes. Alright? So in this case, it's going to take about like 18 minutes to train this model on 160,000 rows. So I'm just going to kick this partition and sampling back down to 1. I'm going to feed it all the Twitter data. Okay? And I'm going to go and predict this. So while that's running, let's build a pipeline. So the model is a very small sliver in the actual grand scheme of things. Right? You still have the pipeline, the ETL, and the dashboard, and everything else in between. Okay, so let's build that stuff now. Alright. This is fun, isn't it? Alright, so does everyone have a Twitter app? So if you go to, so first of all, you have to have a Twitter account. Okay? By the way, they want your phone number. Don't ask me why. I'm on Twitter. Okay, so they want your phone number. But if you go to apps.twitter.com, you can go in and create new apps. So what this app lets you do is it says, hey Twitter, I need permission for you to give me some keys so I can access your API. And an API is just an application interface that I want access to tweets. Okay? So in this one, I've already made one. Okay? So if I go into it, there's a bunch of access keys and tokens. Okay? So specifically, in the realm of tweets and Twitter API, it uses something called OAuth, which is a 4-factor authentication, which you need 4 keys. 2 keys at the account level, 2 keys at the app level. Right? So each Twitter account will have the same thing. By the way, Amazon has the same kind of system. Fitbit, I think, also has the same system. So a lot of APIs use this OAuth thing. I think Facebook does too. Okay? So to open this stream, we're going to use Python. But you can literally use any language you can think of. Because if you just Google, or not, Twitter API languages. Actually, it's on the meetup page. Let's just go down. Alright. So if you're a C# guy or a PHP guy or a Java guy, so this is a list of every single package that will talk to Twitter. On any language you can possibly think of, including COBOL. Okay? Programming joke. Alright. Alright. So Python. See, there's like 1.5 million guys that decided they want to do this in Python. Just pick the first one that works. Doesn't matter. It's all the same. Okay? Ruby, C, C.NET, Erlang, Java, Ruby, T-SQL, VBA, oh god, that hurts me. Alright, if you want to stream tweets into Excel, you can do that. Okay? I can't guarantee that Excel would not crash, but you did that. Alright. So specifically, we're using a package called TweetPy. You guys see that? Alright, so we're going to look at, I think they have the handy dandy documentation open, so I'm going to look at examples. Okay. That is a terrible example. Okay. Let's look at this documentation guide. Alright, so this takes me to the GitHub. And I specifically, so if you haven't already, I would do a pip install. Okay, if you're working with Anaconda, I would do a conda install. If you're working with Python 2, do a pip2 install, okay? Alright, and by the way, it doesn't matter that I'm doing this in Python. This could have been any language, as you saw earlier, okay? So if I look at their documentation page, so I just grabbed a random package, okay? This could have been any package. And I'm going to see how to use it right away. So I think if I type in streaming here, something will show up. Streaming with TweetPipe, sweet, that's what I want. Okay? So what do I got to do? Well, I got to import it. That seems fair. So I'm going to build a script. Alright. So in this case, what do I want? Import TweetPipe. Check. I have to define a class, okay, that will treat these tweets. Perfect. Alright. Oh. Okay. And what do I want to do on status? Sure. Now, I think I don't want to do on status, I want to do on data. Alright. So instead of on status, I'll just do on data. Okay? So as tweets go through on this stream, I want it to do something. Okay, in this case I want to print it. Let's do print data. So I'm defining a variable here, so it's going to pass me 2 arguments, specifically just Twitter data. Okay. So that was my class. What else do I need to do? I need to create a stream. That seems fair. Okay, so I'm just going to paste this in. However, if you notice, I need to pass it some kind of authentication. Right, so if you notice, my stream listener, it's listed up there. Although I think there's a mistake. I think that needs to be a capital M. Sound error in your documentation. Just get a gold star. Okay. In this case, I need to figure out what authentication is, and luckily there's an authentication tutorial here. Alright, so what do I need here? So this needs to come before, I am assuming, Twitter, the Twitter feed. So I guess Twitter needs to know who I am. So in this case, it needs to take a consumer key token and a consumer secret. Okay. Sure, let's do that. Alright, so if we remember back from the Twitter app, okay, this looks kind of familiar, doesn't it? Key, token, access token, consumer secret. Okay? So in this case, I'm going to go ahead and put this guy here, assign them as variables, define them. Alright? And in this case, consumer token. Alright, I'm assuming that's consumer key. And then down here it says consumer secret. I'm assuming that's this, hopefully. And looks like I imported an extra space here. Alright. And where do we put the access tokens? So let's look further in the documentations. Alright, so it looks like I have to set it. So set access token. Okay. So I guess this has to go second. Okay. So it looks like I need a variable called key and secret. And by the looks of things, it should just be these guys down here. So the access token. Okay. And the access token secret. And it looks like I added a bunch of extra space there. There you go. Okay. So those are my keys. So this is going to log me into Twitter programmatically. Now what else do I need to do? Alright, so I have this auth thing set, which means now I need to open up an API. So because down here it says I need something called an API. You guys see that? So in this case, let's go back to the documentation. Oh, API. Sweet. Okay. There we go. Okay? And in this case, alright, so that's going to set a stream. Now specifically, I think I don't want the normal stream. I think I want a different stream. I'm going to go and look into my handy dandy folder and see what kind of stream I actually want. So I also packed in this really nice Python file for you guys. Okay, so in this case, I want a specific stream called a sample stream. Specifically, I care about English tweets. Okay? Alright. Alright, so what does this do? This instantiates the stream object. This turns on the stream object. And when the stream object turns on, it's attached to this listener. This listener is doing something with this data. Okay. So I'm going to go ahead and save this. I'll put this into its own folder, I guess. So this is a Python script, by the way, just FYI. So I saved the tweet and cross our fingers. Hopefully this works. All right, so CD. I'm sharing stew, CD. I need to reference where I saved it. Okay, so if I do a dir, it should be in there. You guys see that? So I will activate Python, Twitter stream.py. Hey, look at that. A Twitter stream has opened up. Ooh. We are now spying on the world. How do you guys feel? Alright. Now how do we hook this up to the cloud? Alright, that's the next step, isn't it? Well, so we've opened up a Twitter stream, now we need to send that into the cloud. Okay, so in this case, actually so right now you can't even see the data. So we should probably format it so we can see the data. So import JSON, because it's a JSON, okay? And I think I can just do JSON.dumps tweet data. Sweet. So this will be my tweet JSON object. Okay, and I want, so there's a column called text. That's the thing we care about. Okay, and actually just to prove it to you, I've added you a sample Twitter data.json. So this is the actual thing that the tweet looks like. Okay, it's a JSON array. Now, hold on, let me reformat this. All right, there you go. All right, so this is how it actually looks. You notice that this whole thing is a tweet. This whole thing is one tweet. Okay? But you notice usually when we tweet, we only care about one thing, and that's the actual text. This guy. Right? We want to grab this guy. I just want to see it. Okay? But did you guys notice that this much data was actually being grabbed? Your location's being tracked in 3 places. FYI. Right? See? Geo. That's one. Country, place. Right? Coordinates. Yeah? And it goes on, right? So, ignore it, just keep using Twitter. Everything will be fine. Okay? Alright. So, what are we doing now? Oh, right, we want to see the tweets. We don't want to see the matrix, we want to just see the tweets. Okay. So in this case, what was I doing? Right. So I was converting it to JSON within Python using a JSON package. Okay. And in this case, if I save that and just talk to it again. Okay. String indices must be integer. Okay. Let's look at why that is. All right. So it looks like.
JSON loads.
Huh?
JSON loads, not those.
Yes, loads. Yes. Good, good. So I did the opposite. I said turn this into a JSON. Or I said turn this into a string versus turn this into a JSON. Alright. Alright, so Unicode error, which means I need to encode it. So dot encode UTF-8. Alright. All right, there we go. Now we got tweets. You guys see that? Awesome. All right. Now that we're already spying on people, all right, let's predict their behavior. All right. So I'm going to stop the stream. All right, cool. Now what we want to do is we want a method to put it into the cloud. Because there's two problems here. My laptop cannot process all of this data. It just cannot. I'm going to access the power of the cloud to do it. Okay? So if you're doing this in AWS, this would be Amazon Kinesis. But specifically, we're using Stream Analytics in Azure and Event Hubs in Azure. Cool? Cool. All right. So an event, oh look, it's done training. Let's actually see how well it did. Do you guys remember this model? This is the, it's still God. What the heck? Look at this thing. Oh, I know what. I think yeah, I have no idea. I'm doing something very wrong. FYI. Right? My model should be nowhere near this good. But I don't have time to troubleshoot it right now, so well, let's assume that this model is good. Okay? But don't ever deploy a 100% model. Don't ever. Okay? Alright, so we have our model. Okay? And in this case, I'm going to go ahead and set it up to become a predictive model. So right now this is just an experiment. Okay, it's going to run through, it's going to figure things out. But I'm past that point. Okay? What happens when a live data set comes through? It's not going to bring with me the sentiment label. Alright, so I got to do what's called now deployment logic. Okay? This is called data science-y logic. Okay? We're actually doing deployment logic now. Okay? So what do I need to do? The data needs to be cleaned by the time it gets to the model. Okay? Because that's what the model was trained on. It needs that same matrix. Okay? That's the second part. So everything I did needs to stay the same. Alright, so let's do that. So an Azure ML has this fancy schmancy deployment button. Okay? And I don't know if my laptop can handle it, but it's gonna, oh! Alright. So it saved my model. So this prevents my model from being retrained. If it retrains in the model, I've lost my coefficient. That entire week I spent cross-validating, finding all those parameters and all that stuff is now lost if I didn't save this model. So that's what I did. I saved the model. Alright? So what is this going to do? You should think of this as a function now. Something goes into function, something goes out the function. Things happen in between the function. This is the in-between. Okay? So the into is this web input. When you call this as a function, it goes here. Okay? And specifically, I don't want it to do any partitioning. I want it to clean stuff. So in this case, you notice I have two tabs, right? The predictive experiment and the training experiment. Right now I can do anything I want because this is the deployment logic. Okay? So I still want my tweet to come in. And I still want my tweet to just go ahead and also be scored. Okay, so in this state, I also have only one column going in. This time when I call this function, I'm only going to send it the tweet body. I don't care about the label. So I need to remove the label. So right now I'm defining a schema for which this model is going to see. Does everyone understand that? So a schema is now it needs a text body that's a string. That's all it needs. But right now it's got two columns in it. Okay, so what am I going to do? I got to drop the sentiment. Okay? So whatever this guy touches, which is touching this guy, it's going to grab the schema of that. Okay? So in this case, I'm going to go ahead and start altering this schema a little bit. I'm going to go ahead and exclude the sentiment label. Okay? So by the time it gets here, there's no sentiment label, just a sentiment text. Now, it's going to go through, it's going to partition 100%. I'm not sure if I need that, so I'm just going to drag it down here to increase performance. Okay? Remember, we have to optimize for speed. That's why we chose support vector machine. They're very fast models. Okay, we care less about accuracy. We're going to sacrifice a bit of accuracy for more, to get the answer back quicker. Okay, so that's one thing that most people don't talk about with machine learning, is that sometimes you have to give up the accuracy, because sometimes a person on a phone that's clicking a button isn't going to wait for your predictions to come back. When you buy a book on Amazon, there better be recommendations instantly, right? So sometimes they might not be accurate, but at least they get it back, okay? At least they're keeping using your website. So in this case, oh, this one's casting the sentiment label. So I'm going to go ahead and actually reconnect the sampling up here, just because this thing is transforming sentiment label. You guys remember that? It was making it categorical into a string, and this was making it positive and negative. We don't really care about that for the most part. So let's connect it at the very bottom. Now the problem with doing this is in the execute R script, I refer to it explicitly down here. See this? Sentiment label? I don't have that anymore. So I'm going to delete that. I'm also going to delete that. Okay? And it's going to go through, it's going to hash. That's what we want. It's going to stem. That's what we want. So this is what? An automated text cleaning and matricification thing in the cloud for us. This is going to be awesome. Okay? And now it's going to drop the text column. Fine, we don't care. And it's going to go through and do a bunch of transformations, which I don't know what it's going to do. All right. Oh, right, it's going to normalize. That might be important. Let's bring that back. Yep, all numeric columns. And min-max. Alright. And you notice that this is going to output something. What is this going to output? Huh? The sentiment and what else? 65,000 other columns. Right? That would overload any API feed. Okay? Because I think most API feeds have 256 kilobyte max payloads. So in this case, let's drop everything. We only want positive and negative back. Alright, so in this case, I'm going to project out literally everything. So in this case, I'm going to include only the scored label. So the scored label is positive or negative. The scored probability is the percent chance of it being positive. If it's over 50%, it's going to go ahead and be positive. If it's less than 50%, it's going to go ahead and be negative. Okay? Alright? And now, oh, I forgot to actually apply it. So right now only this label is coming out, and specifically I'm going to do a little bit of extra cleaning as well. And I'm actually going to name my column. So right now it's called a scored label. That's not very clear. I'm going to call that column sentiment. So it's going to bring me back one column called sentiment. If I run this now, hopefully nothing will break, but that's how live demos work. Things break. Any questions while this thing is happening? Okay, speechless, I guess.
So Phuc, I was speculating in your previous model when you got the perfect term.
Yeah.
By any chance, do you feed the labels as well?
I might have fed the labels, yes. So that's what I'm afraid of.
Yeah.
Yeah. So if I fed it the labels, that means it got the answer, right? Positive or negative, and it used that in its prediction. Okay? Which, big no-no, okay?
How do you push data to the model?
We're about to see that. So right now we're setting up a deployment logic. We actually haven't deployed it yet.
Oh, okay.
Yeah. So I'll show you how to push data into it once this thing is successful. Alright, so let's go back to our pipeline. So this is the model. It's going to train. It's going to do its thing. Let's go back to the model. Remember, we opened up a Twitter feed, and it's just showing up on my console, and it's being dropped. We need to funnel that into the cloud somehow. Okay? So we need to use some kind of messaging queue or data ingestion tool. You know, if you're used to Kafka or RabbitMQ or Amazon Kinesis, Specifically, we're going to use something called an event hub, because that's just way quicker. It's like easy mode for message queues. So if you ever develop, you might want to start off with an event hub or a message queue in Azure. Okay. So specifically, we're going to go into Azure. So this is the Azure portal. Okay. I need to set myself up two things: a stream processor to process this data. Okay. So if you guys know Apache Storm, it does the same job. Okay. Or Spark Stream also does the same thing. Or Amazon Kinesis. Okay. So in this case, we're going to set up a data ingestion point. So in this case, we'll do what's called a service bus. Okay, so it's called a service bus. This is just an empty computer. It's a computer. A service bus is a computer that's sitting in the cloud that's optimized for high-speed intake and high-speed outtake. It's just a gigantic computer with a gigantic switch on it, I'm assuming. With really good internet connection. So in this case, I need to make myself a service bus. And specifically, I'm going to make myself an event hub. Okay? And if you want to talk about the differences between all these queues, you can talk to me after. Okay? Alright, so in this case, we'll do West US. But it really doesn't matter because the speed of light is very fast. Okay, so I actually need to go to the service bus and create a new one. So I'll call this Clark Kent Space. Okay, so I'll make it a messaging with a standard queue in West US. Okay, basically this is good. Clark Kent Space. Nope, that's taken. Really? Alright, Wally West Space. Okay, cool. Awesome. Alright. Who knows who Wally West is? No? Okay. Oh well. It's the Flash. Okay. You notice that there's Bruce Wayne down here? Alright. So, we'll create a Wally West space. So it looks like it hasn't provisioned the event hubs yet, so let's do an event hub. So we'll create an event hub. So we just provisioned a computer called a namespace. Inside that computer, we're going to install software called an event hub. So we're going to quick create, let's call this Twitter raw, I guess, in Wally West space. Okay. Ooh, I have 30 minutes left. I wonder if I can do this. Arrgh. You guys don't mind staying later, right?
Yeah.
Okay. So it's creating me an event hub. And if I open it up, okay, this is ready to receive data. However, I need to add keys to it. Okay? So if I add, so specifically, I need to have a send key, so a key with permissions to push data into this hub. Okay? My stream processor wants a manage key, so I'm going to give it a manage key. And specifically, I want a dashboard later, so I want to listen in on this hub as well. Okay? So I've created 3 separate permissions here. 3 different jobs. Okay? And once this is done, you see a key. Does this look familiar? Twitter had this guy, right? So does everyone understand that when you're reading from some kind of API, you are looking at the other end of someone's queue? This is how you sell data. So positive and neutral. I've added value to the data. Right? I can sell this to somebody. I can just filter out like Nordstrom tweets and sell this to JCPenney. I don't know. Right? So that's the idea. Now, that's done. So how do I push data into this thing? Well, that's what Google's for. I'll do Python, Azure Event Hub. Beautiful. The Service Bus SDK came up. All right. By the way, you could have done this in any other language. Java, C#, whatever, okay? So in this case, since I'm on Python, let's just use Python. All right, so this is a service bus. I need an authentication, right? This looks familiar. Twitter also wanted authentication, okay? So in this case, I have too many windows open. Okay. So I built an app in C# that lets you look inside of this hub, and I've included it inside of the MeetUp folder. It's called the Event Hub Streaming Dashboard app. I'm sorry, Mac users, this is a .NET app, but it's fine. Just follow along what I'm doing here. Okay? But there's also documentation on my GitHub on if you want to set this app up in C or C++ or Java. Okay? So in this, I want to listen in to this hub, right? So I have a listen key. Right? If I view connection strings, there should be a listen key. I'm going to grab the listen key, paste it in, and specifically this is called a, oh, not a credit hub. Ah, right here. So I'm in the Twitter hub. Okay, so I'm going to view the connection strings. I want a send key, cool. Oh, not a send key, I want a listen key, because remember, this is a dashboard. Okay? And then, this hub is specifically called Twitter Raw, so I'm going to paste that in as well. Okay. Alright. So each partition, by the way, is just a separate hard drive inside of this thing. This is how it scales. When you fall back behind on real time, you keep adding more hard drives. So you get more readers and writers, right? So you never fall behind. So there's nothing in here right now, right? So let's push something into here and see if we can do it. So specifically with Python, okay? So let's set up a new Python script. I could have sworn I had a Python script already. There we go. 2 plus 2. Good. Okay, it works. Oh, that's not it. Alright, sure. Alright, so what do we got here? Just gotta make sure this works. So, I need to give myself authentication. You gotta stop leaning at that. Sorry about that. Alright, so I gotta import this package. So by the way, it's pip install Azure. That's it. It's gonna install a million things. Don't worry about it, okay? So, in this case, from Azure.service bus, import service bus. Cool? Okay. In my key, well, let's take a look at that. So my key name, if you guys remember, I called it send. Okay, so I'm pushing data in right now. If I go back to this, my key value, well, okay, that gets a little more complicated. Okay, so I need to find my key. So my key is actually back into the configure area. So if I look at my send key, I can copy either of these keys. They do the same job. I get an extra key basically, a backup key. Okay, so I'm going to copy one of these keys. Okay. Just got to make sure it's right. Okay, so specifically, I need to instantiate a service bus connection, or a service bus object, to be more specific. Okay, so I'm going to go back into my route. All right. And my service bus namespace, I think I called it Wally West space. In quotes. Alright, no errors yet. That seems good. Alright. Now what? Okay. Now if I go down here, so this is a different authentication. It's deprecated now, so don't use this one. It's not as secure. So if I want to send messages to an event hub, okay, there's a send right here. Right? So if I do this, I would do Twitter Raw is the name of my hub, you guys remember? And this is the payload that it's sending. So it looks like I just have a hello world data set here, right? So if I look at this, there's nothing in here right now, but if I press this button, it should have sent something to the cloud. Alright? Now it's a matter of just hooking it up. When Twitter goes through, send it into this guy. Right? And I'll just do a quick demonstration of that real quick. So, see this line of code? cbs.send event. Well, remember the streaming thing? Instead of printing it, right? See that? I can send it directly into the hub now. This is true of any other messaging bus, Kafka, message queues, Kinesis, whatever. Okay, it's just an HTTP call. You can curl this. Okay? Alright, but through the miracle of time, I built you an app that does this for you. So, if you go to demos.datasciencedojo.com, I built an app that just, you give us your Twitter credentials, and we push data into your hub for you. Right, you see that? Alright, so, you just give your credentials, you say how many tweets you want it to push, and you're good to go. Okay? So, that's cool. I have a hub that's now receiving data. Okay? Now if I want to, I'm pushing data into the hub's going to store data for me. As a stream, I need a stream processor to hook up to that now, calculate things. Okay? So I'm going to create something called a Stream Analytics app in Azure. So this is just a powerful stream processor. Okay? So in this case, I'm going to type in, I don't know, Twitter MeetUp. Okay? So this will be in West US. Okay. Let's go back to our model now. Hopefully it didn't fail. I was still thinking really, really hard about it. I should have sampled down. Because remember, all it wants is a schema. It doesn't actually need the rest of it. Well, I think it's at 5 more minutes. So let's build the rest of the pipeline. Okay? I think we can do it in 5 minutes. So, let's go back to this. So, if we look at the Twitter meetup, this is a stream processor. It has an input, it has an output, and it has a query. Long story short, what goes in, what goes out, what happens in between. Okay, so let's define the what goes in portion. Okay, so in this case, it's got a really nice connector built in for event hubs. No programming, which is great. Okay, so we click add input. If we add a data stream, we can add an event hub now. Okay. Now, from our current subscription, Wally West space. Now, by the way, so through the miracle of time, actually, let's just send it to Wally West space. Let's just do that, okay? And I will give it a manage key. And I'll give it its own consumer group. So the consumer group is just a dedicated line of readers and writers. So two things, the ones you read from this hub, they won't collide and fight for those readers and writers. Long story short, it keeps latency low. So if you want to do high-speed reads and writes, you can do that. Okay, this is required because it's Twitter. Lots of data is being pumped through. Okay, so I'll call this Twitter Meetup, and specifically as an input alias. So this is just a variable name. I can call this whatever I want. Okay, but in this case, just to be descriptive, I can call this Twitter stream. Okay, and yes, it's a JSON. Okay, beautiful. Okay, so I need to enter my own credentials here. Now I could have done this programmatically, but we don't have enough time, so we're going to use this app that I built. Okay, same logic, literally the same logic. Okay, it's just taking JavaScript and passing my variables instead. Okay, so my hub name I think was called Twitter Raw. My service bus namespace I think it was called Wally West Space. Policy name it was called Send, and I need to give it myself a good key. So if I go back to this guy, Wally West Space. Figure out what my key was. Copy a send key. Alright, so it looks like one tweet got into the hub now. Okay? So, the handshake is now made. One tweet went into my hub. Okay? So what do I want to do now? So if I click at inputs, I've added this event hub. Right? I haven't started the stream yet. Notice the start button is in gray. But I need to sample the stream to make sure the connections are okay. What am I doing? I'm just sticking my hand under the water, or under the faucet, making sure it gets wet with data. So there should be one tweet in there. So if I sample data right now, I should find one tweet. And specifically, why don't you finish? Was 15 grams not good enough for you? Should have made it 10 grams. Made a very bad model, but whatever. Okay. Okay, so I'm going to make an output hub. Okay, so what is it doing? Twitter feed goes in, the website, basically the server of the website, which has a Python backend, sends it to an event hub. The event hub sends data to the stream processor. The stream processor processes the data, and eventually we'll hook up machine learning to the processor, and we're going to output it to anywhere we want. But for now, let's output it to another event hub so it stays a stream that you saw earlier, positive and negative stream. Okay? So, in this case, I'm going to go back to Wally West space and add another event hub, and I'll call this processed, or actually Twitter cooked. Okay, remember earlier before it was Twitter raw. Okay. All right. Beautiful. So this is going to be an empty hub. I need to set the same kind of specifications I did earlier as well. So let's give it a send key. So by the way, this is two-factor authentication. So I could have easily added a separate key right here, and this would have been two-factor. Okay? What I'm doing is very insecure. You should not be doing this. Okay? Alright. Boom. Alright, so I got another hub that's empty. So this is an output hub. Before it was an input hub. Okay? This is how pipelining works. A lot of hubs. Okay? Alright, so I'm going to stream analytics again. Oh my gosh, really? I'm going to save as. Okay. You know what I'm going to do? I'm actually going to partition this. No, that's too much. Alright, so I'm partitioning this down so it goes faster. So normally if you did this on a real data set, it might take like hours or days to train this. Okay, so just FYI, machine learning takes patience. Okay, so hopefully that will finish, and if it doesn't, let's monitor the other one too, just in case. Because we need to hook this thing up eventually, before the end of the night.
So this is going to sit between the two hubs?
Huh?
This is going to, the model is going to sit between the two hubs?
Yeah, so the model between the two hubs is a stream processor. Okay, in that stream processor, we can call Azure ML. Okay? And yes, question?
Can you draw out the hubs?
Yeah, that might help. All right.
The service bus?
All right, so you got Twitter. It's reading from my API. Okay? From that, it's going into hub A. Okay? This is one hub. Okay, and this is via Python. It could have been any language. Specifically, it's going into a stream processor. Okay? Transformation happens in here. Live. Okay? And now we have a processed hub. Just call it hub B for consistency. Okay, and in between that, we're also going to have this thing reference a predictive model. And as you saw from everything I've done today, there's a million and one ways you could have done this. On any language, on any stack. Okay? This implementation I found was the easiest and quickest to implement, so that's why I chose all the technologies that I did. But you could have easily done this in any other stack, any other language. Okay?
So the hub that will go to the dashboard?
Yeah, that hub will probably go to a dashboard. that last hub, the process hub. Because remember, whatever's in that hub, that's going to be interesting. Okay? The first hub was just raw data. I did not add value to that data at all.
So your stream processor not only transform the data, also then apply the learning results.
It will once this thing is actually done. Alright, well, hopefully this will finish a lot quicker because it's only been 2 minutes. So it's only processing 160 or so things now. Okay. What I should have also done is I should have also done filter-based selection on features. So I made it basically feed in every like 65,000 rows, regardless, or 65,000 columns, regardless of whether there was a word in that column or not. What I should have done was I should have done some kind of correlation, like a Pearson's correlation. Grab maybe the 5,000 most correlated columns and feed that into my model instead. That would have had more weight. That would have made my data much less sparse. Okay, and it would have just filtered out the columns that had none. Right? Maybe the word Harry Potter, there was a column for Harry Potter, and Harry Potter wasn't mentioned once. Right? Alright, let's go back to our pipe. So in this case, I have an output. So let's add an output. So specifically, it's another event hub. Okay? And it's in Wally West space, and remember I called it cooked versus raw. And I'll give it the managed key. I'll call this hub, I guess. It's just a variable name. Sure, I'll keep you as a JSON. Actually, let's keep you as a CSV. So you notice it went in as a JSON. The stream processor is now going to convert it to a CSV coming out, which is awesome. Okay? Really? Alright. So through the miracle of time, I already have a model built. Okay? See those infomercials where they just put a turkey into the oven and they're like, oh, in this other oven, it's already done. So I'm going to use one of those models, if you don't mind. Okay? So So it looks like in this one, awesome. So it looks like it did the same thing. Okay, so what I'm going to do is, since this thing is deployed, okay, once you click this deploy button again, it builds you a web service, okay? But I can't really show you that because it's already deployed. So here we go. So the idea is you will see this page once it's deployed. Remember we had an input, and then it fed through the text processing. And then it touched our model, and then after the model, what we did was we dropped every other column. That matrix that came with us, we dropped that matrix. And then we renamed our column to be sentiment rather than scored label, because that's way more descriptive. And this is your API help page, right? So this is API, this is your API key. Looks familiar? Everything in the cloud is a key. Right? Because everything in the cloud is essentially just a website. What's stopping someone from just accessing your awesome storage or your awesome model, right? Just lots of keys. So if we click on test, you see that it's going to ask for something called a tweet text. Where did that come from? Remember our web service input? It's going to grab the schema. That schema of the input was at the point where it says text tweet. Remember, this is after we dropped the sentiment label. Okay? So in this case, we can say the brown fox jumped over the moon and killed everything. Alright? I don't know. So if I fire that off, what is this doing? This is just calling my model. It's going to go into Azure ML. It's going to clean it. Stop where it's gone. Vel is gone. Remember, the brown fox just becomes brown fox. Okay? And we go through, and it says it returned negative. Right? So what does that mean? The word kill was probably negative. Right? I'm not sure what cow meant, but actually, let's see what cow means. Actually, let's have fun. Let's have fun. Donald Trump. Hillary Clinton. Just type in Clinton.
2 hours.
So, for whatever reason, Donald Trump is positive. Okay? Also, Clinton is positive. Okay? But by the way, our sample data might not have ever seen Donald Trump or Hillary Clinton. That's something to consider. This is old historical data. It's like 2012 tweets. Okay? Just FYI. Okay? And by the way, if you parse data, make sure whatever data set you're coming from, you figure out what their cleaning method was. So for example, I used to do Amazon book reviews as because remember, each book review has a star on it. From that, you can figure out that's kind of their sentiment. But the problem with Amazon is they filter out the really, really negative ones, the ones that have swear words in them and all that stuff, right? The ones that are bad, the trolls, right? There's human there filtering it out. Well, the problem with that is the internet is not that nice, okay? And later on, if you say, this effing sucks, the model never saw the F word, right? Which is important in the internet. Just considerations, okay? All right. So, if I click on my response page, okay, here's my post URL. This is just an HTTP call. You can do this in any language, okay? Specifically, it tells you what my payload needs to be, what my return payload is going to be. Okay, so it takes an array of arrays. So each data point is an array. So if you have lots of data points, it's an array of n data points. Okay, and look, preloaded code, Python, R, C#, go crazy. Okay, but that's not what we care about. We care about operationalizing this in the stream processor, right? So we want it to do that. Actually, when a tweet comes into existence and touches our stream processor, can it talk to this guy? All right, and they built a really cool connector tool that lets you do it. So before how you do predictive analytics, you actually had to hook that up in an app and basically just build a really, really big instance of that app, like maybe a 512 gig RAM instance of something, and just quad core and just let it do its thing. All right, but the thing is, you have a stream processor now, and we can add things called functions. Add a machine learning function. I wonder what that means. All right. So if we do this, if I reference my workspace and say that I have a model built already, it's called Twitter sentiment, now I can tell it which endpoint to use. So by the way, if I was doing this in parallel processing, if I had multiple stream processors, I can have lots of endpoints with their own computers and stuff like that. Okay? So I get to call it a function now, predict. Just a function name. I'm defining, it's the same thing in programming when you get to call your own function. Boom. Okay? So I have a function. It takes in one parameter. That parameter is a string. All right. So if I go into my query, anyone here know SQL? All right. So select star from Twitter stream. Now specifically, I'm going to select the text. I'm going to select created at. Okay, text as stream body. Now also, I want to call that function up, predict. Feed it the Twitter body. Save the query. So what is this doing? It's only grabbing the data of the tweet, it's grabbing the text of the tweet, and it's calling my Azure ML function, the model that I built, which is going to bring back positive or negative, remember? And if I start this thing, hopefully it works. If it doesn't, oh well. Okay.
Does this run on the stream that you're...
Yeah, I'm about to turn it on. So if I start this, so it's going to provision me a computer and it's going to say, apply all these instructions to that computer. So this is just a virtual machine in the cloud. It's giving me a virtual machine right now. So this will take about 2 minutes to do it. while that happens, let's look inside of that hub and see if there's anything there. Remember, there should be one tweet in the raw hub and no tweets in the process hub, right? Okay. So I'm going to specifically look at the cooked hub, and I'm going to listen to it. So I'm going to grab myself a key. Okay, remember that tweet that I sent in earlier? This is that tweet in all of its gigantic glory. See that? Remember, this is the text. The text is the only thing we care about. I had to unfollow you because you were a nasty on Twitter. Shrugs. Okay? Right? Alright. So whoever that person was is famous to us now. Oh, cook. Nice catch. So this app is so buggy that it will just crash if I say it wrong. So, warning. Oh, see that? Oh, cooked. Okay. But yeah, you saw that bug. All right. Hopefully, it opens up. All right. I should see the partitions. Silence. Empty. All right. So let's see if we can fill it with data. Oh, hey, it's running. All right. What do you think is going to happen when I feed it data? Hey, look at that. See? Negative, positive. All right, let's sell this data. How do we sell it? All right, well, let's talk about it. Let's actually look at the Twitter data. We're only selecting like 3 columns, right? So, but there's lots of things in there, okay? See this guy? Yeah? I think we can filter by that. Alright, so, really, you're still running? 30 minutes, okay. So, if I go back to my stream processor, I'm just going to go to this stream processor just because. So I can't change my query while the stream processor is running. But hey, let's just do it now. Alright. Select hashtag. Where hashtag is like JC Penny. So we could call JC Penny up and be like, or we can call Nordstrom up and be like, hey, Nordstrom, I know what people are saying about your competitors. You want to buy this from us? $1 per 1,000 tweets, right? But you can really easily turn this into a brand management portal. Okay, so let's say you said this is Donald Trump instead. You can track in real time how people are feeling about Donald Trump. That'd be pretty interesting during a debate, right? So let's look at that. Let's see how we can build an actual dashboard using all of this. Okay? Any questions before I move on? All right. Let's go make money. Let's be rich.
Hey, can you pick Bernie Sanders instead of
Huh?
Trump?
Yeah, we can do Bernie Sanders. Yeah. I'm not actually going to filter by hashtag. I'm just showing you that you can, because I'm getting 1% of 1%. I can't guarantee that someone will be talking about any of those hashtags anywhere in the world at this time. Okay? Unless I get the actual fire hose key, which is like 500 to 800 a month. Okay. All right. So in this case, I'm going to go ahead and stop this. Oh, there is something I do want to grab. Longitude and latitude. Let's graph this on a map. And then let's have a pie chart of each city on how positive or negative they are. Right? Alright. I know it's 8 o'clock, but I'm gonna continue. Is that okay? Yeah. Awesome.
Absolutely.
So this is stopping. So while it's stopping, I'm going to grab a few things. So there's something called an ID string, which is basically the Twitter ID, the tweet ID. So if I want to count things, I need to count the ID, because that guarantees uniqueness. I can't count dates, because 4,500 tweets a second, you're going to get a lot of collisions there. Okay? So I need to grab the ID if I want to count. And I'm also going to grab the long latitude. Alright, so I can delete this now. Let's add Power BI. And if you don't know what Power BI is, it's basically if you took Excel and merged it with Tableau, that's what it is. Okay? It's just a really powerful data visualization tool. So I'll call this Twitter Meetup. Data set will be come in. All right. Let's start this guy again. This time, we're going to PowerBI.com. And now we're going to spy on people. So we were already spying on people, but now we're just going to add a map to it so we can really see where they are. Okay? So this is credit card data. Ignore it. Okay? Ignore it. Alright. So as this goes through, by the way, you could have switched out this data for any other type of data. Made it real time. Credit card data. Any other type of data? Yeah. Just switch it out. Okay? Model's a model. Stream process is a stream process. So it's going to take about 2 minutes to start. Does anyone have any questions so far? Yeah. Longitude, latitude.
How do you define the granularity of like?
So
when you do
so the granularity is actually I don't want granularity there. I want it down to the decimal point. Right, so maybe it might be at the block level or like the neighborhood level, but it might not be at like the house level. Specifically, it doesn't make sense to go down further than the city level, because then your pie charts look really weird.
So where do you come from?
You actually do that either in the Python portion, or you do it in this portion, where you can select a substring of the longitude and maybe increase the decimals or decrease the decimals. That's about it. While this is happening, I'm going to send one tweet through. See if our model's done. Alright, still thinking about it. Alright, I'm just going to stop it. By the way, if you want to know how much any of this costs, you go to Azure Price Calculator. AWS has a price calculator too, so if you're doing this in AWS, this is fine. So, Specifically, I'm using something called
Machine learning.
okay, there we go, machine learning. Okay. All right, so I've used what? 2 hours so far. One seat. So I've been charged $1. Okay, and my API, basically API, anytime I make a call to this thing, basically anytime a tweet goes through, it's going to make a call, an API call. Okay, so in this case, thousands of transactions. Okay, so I doubt I'll reach 1,000 today. But let's just say I have 1,000, so it's going to charge me 50 cents for tonight. Okay, and compute hours, since we're using a support vector machine, aha! We have barely any compute hours. So let's just say it's less than $2. Okay. Oh, have you guys seen cloud storage prices lately? It's ridiculous. Let me show you this real quick. So, AWS S3 and Azure Blob, same price point. Okay? For a gigabyte, 2 cents a month. It's crazy. Right. Data is so cheap now. Or data storage is so cheap now.
When you train the
Yeah.
cost of the compute there,
Yeah, the cost of the compute is in hours, right? So in this case, I ran a model for 40 minutes now, right? So whatever that times, whatever that rate was. Let's look at that rate. So in this case, I did 1 hour, so that's $1. Okay. Start again. Okay, sweet. This has started. Okay, so let's stream a bit of data. By the way, if you need to leave, just leave. This is extra. Okay? So, alright, so I pushed the tweet through. Where'd that go? Alright, so the data is showing up in Power BI. Location, yay! And we'll do it on count of distinct Twitter ID. Alright, so this whatever tweet that was is this Malaysia or Indonesia? Philippines? I don't know. So there's that. I'll create myself a new dashboard. Yeah, sure, I'll save it. Okay, so I'll pin this to the dashboard. Yay! Okay, so let's make myself a new. Let's add some more visualizations, because managers love visualizations, right? All right, so let's impress our boss. Okay. So let's do a pie chart. That's a pin this as well. Okay. All right. Let's actually read what the tweet says. Beautiful. And that as well. What do you think is going to happen when I stream data into this thing? Ah, We're spying on people at an industrial level. I love it. Let's crank the Twitter up to 500. Oh, there's a stream processor, remember? Feeding this real...
Once the data goes to Power.
Yeah, let's give it a couple more seconds.
Can you monitor the problem? Is there?
Well, technically the monitoring should happen in Power BI, right? So I think it's setting up the connections right now, but usually it's instant. So the act of adding a predictive model to a stream processor actually slows it down quite a bit, because remember, the predictive model is usually the bottleneck of this whole pipeline. So usually you want to parallel process your stream processors and add multiple endpoints to your machine learning model. So basically what it does is just clones your model across multiple computers and calls, basically with a hash algorithm, random computers. So at any given time you get load balanced on your stuff. I wonder what's up. Sure. Let's actually look in the hub and see if anything's happening in that hub. That's a good way to troubleshoot. All right, look at that. So a lot of tweets came through. Now, I don't think I mapped this correctly, so let's just ignore the pie chart on the globe. Maybe let's just do mapping of just tweets in general. Right? Oh, hey, see, that works. Yeah, let's spin this guy. Yeah, so imagine this, but with pie charts of each region, showing how positive or negative the region was about whatever it is you were filtering in your stream process. So this could have been Bernie Sanders or Chevrolet or whatever it is you wanted to keep track of, keep tabs on. Maybe a Justin Bieber concert was happening, and you cared whether or not people liked it in real time. Okay? Let's see. Hey, look at that. So they're working on natural language processing right now for this thing. So you should just be able to type in questions and stuff comes out. But I'm not sure about the documentation on that yet. So it's just a fun toy at this point. Any questions? I think that's it. I think that's all I want to cover. I don't know what happened. Well, I think I built that model wrong to begin with. And we could have probably seen that from, remember, it was 100% accurate. That should never happen in any model. Yeah, that's normal. So right now you're like 60% above 50%, which means 50% is the coin flip, which means you're slightly better than a coin flip. Slightly. Yeah.
For the event hub, you use like an external application, but is it possible to see like what's in the hub directly in Azure portal?
No, there is a 15-minute delay on that portal. So that's why I built that app that lets you see inside the hub in real time. So basically get stuff from the hub, print it to the console. That's all it does. I've linked it actually in that GitHub. So if you look on that folder, there's those instructions. There's a link on how to test and read data from the hub via C#. But that same page also has Java, C, and other languages in case you were more interested in different languages.
Do you think the data transferring from your laptop to the event hub, would that be a bottleneck too?
Yeah, of course. Your laptop is a bottleneck. That's why we wanted to use stuff in the cloud, right?
Seems like once it's not transferred over.
Yeah, once it's in the cloud, you are accessing commercial quality data centers, right? They have really powerful computers, like that is beyond our scope. It's like custom built Intel stuff. So.
So when you add more endpoints to the model,
So when you add more endpoints, yes, that is not auto scaling, it's manual scaling, right? Because you're adding a separate computer. Basically, each endpoint is one computer, right?
then you have to keep track of all the...
Yes, you have to keep track of your latency. How far behind are you in seconds from the actual real-time point of data? Because remember, it's going to go through and it's going to process data in order, in FIFO order. First in, first out. If it falls behind even by a second, that's 1 second each second that's going to come behind. So over a minute, that's 60 seconds behind. Over 2 minutes, 120 seconds. So it's very important that you always have more capacity than what's going through.
At least most of the last part still going to the other key, but under SD content. I'll have an SD reader on this machine. I can't actually pull it off, but if you have one, you can pull it off if you want to grab it.
Oh, yeah, is it on there?
Yeah, huh?
Thank you so much. And like, do you want us to like credit you on our, because we like to upload it on our YouTube channel.
Oh, yeah.
Do you want us to like credit you?
Oh, I have a conference call now.
No! Well, it's okay. It's all right. Yeah.
No, I have a conference call.
So is the last one still on?
Oh, yeah, it's still recording. We talked it actually.